The original genesis of spike feeding in general came about because of looking for methods to increase productivity, safety, overall operational improvements on a tie gang.
Well, currently it's a manual process. There's a third operator that's in the cab with the two spikers. The operator then has to take the spikes and feed them manually into the separate spike trays. And he has to make sure that they're orientated correctly. Being a human, he makes mistakes sometimes too.
Extremely inefficient process, definite safety concerns, and that was when we started to reach out to the railroads and said, what are some things that we can do for you? How can we improve this overall process?
Some of the early designs looked more like medieval torture devices than anything we'd sell to the railroad. They were conveyors that have belts that were spinning. They'd have, we even took a lawn roller and added spikes to it, and we put that down in the bulk bin to try to get spikes out. Eventually we stumbled on the singulator design.
The singulator consists of 4 parallel stages that deliver a dual path of spikes to the main conveyor.
The first 2 stages work together, equal and opposite motions. So when stage 1 is down, the wedge delivers spike to stage 1, and then stage 1 will lift up to stage 2. That will deliver spikes to stage 2, and then stage 2 will lift up and stage 1 will go down. So it's equal and opposite, and that helps the spikes to reduce in quantity and also travel in the singulator. And then when it gets to stage 3 and 4, it splits into 2 paths. So stage 1 is this wide, and when it gets to 3 and 4, it gets narrow. So now you get 2 paths of spikes coming out of the singulator.
The main conveyor then delivers those 2 separate flow paths to the feed conveyors.
The spikes exit the singulator and they continue on to the main conveyor system. And the main conveyor system is basically 2 conveyor belts. Each of these belts are powered by a separate hydraulic motor. Each of the conveyor belts also feed one of the 2 cross conveyors. And as the spikes go onto these cross conveyors, they're fed to each of the 4 work heads depending on what mode the system is put in, either rail or gang.
Well, we started with a clean slate, so to speak, as to how are we going to turn the spike head. We want to end up with the spike in a precise location. All of the spikes have to be exited the orienter to the tray above the hammer, pointing in the correct direction. The spikes enter the orienter and they could be pointing anywhere, I'm going to say in like 4 quadrants, if you think of it that way. And one of the quadrants ends up being the correct location, so we simply need to pass that spike along and let it be in the correct orientation. We need to turn it twice, and the system allows us to do that. The other issue with the inlet is we can't overfill it. We want to make sure that we have just the right amount, so there's a proximity switch that will allow us to fill the orienter to the height that we want and then turn the system off.
With the productivity increases, they get to do more track maintenance, and I think that becomes the key. If they have a certain track window that they're trying to work within, let's say 4 to 6 hours, being able to spike more ties in that 6 hours makes them more productive, gives them the ability to really run their trains faster, which is what they're in business to do.